Hi.
Hey, Christoph.
I'm just going to test my audio here because I had really bad issues this morning during the poster session. Hi.
So it seems you can hear me, right? Okay.
Yeah.
I can hear you.
Is this loud enough or?
I can hear you very well.
Perfect.
Are you guys able to hear me fine?
Yeah.
Yeah.
Are you planning to talk live or do you have a recorded video?
It's a live talk for me.
Oh, yeah.
Yeah. I have recorded a video yesterday, so I will just play it.
Okay. Yeah, I also have a video. It's the first time that I do it not live with a video. So.
I can test the sharing. Seems like it's working.
Yeah.
Okay. Perfect.
Okay. Yeah. Let me test my video too. I'm the author of does that work okay?
Yeah.
Packages. Okay. If you update. Okay, great.
I have a question. Could you hear your own video? I am playing my own video. I cannot hear it, but
I can hear mine.
you can. Oh, okay. So then I will okay, try mine and see if you can hear it. Not that something is wrong.
Oh, my audio's gone now. Okay.
I'm from the University of Mainz in Germany. Today I will...
Can you hear it?
Yeah, that
Yes?
sounds
Okay.
perfect. Yeah.
Okay, I cannot hear it, so it's really weird. Nice that you can hear it. So I have to remember what I said 11 days ago.
So it's 15 minutes, right? And 5 for questions. Or are the questions all at the end?
I don't know.
Yeah.
Jane, do you know?
Sorry, what's the question again?
Like I understand it's 15 minutes the talks and 5 minutes for question, but are the questions grouped at the end of the session or after each?
I think we'll do it at the end of each talk so we don't completely forget your things, and then you can go back to the slide and share if it illustrates a point.
Okay. And should we pick the question in the QA panel, or will you like select some of the questions?
I guess, how do you guys want to do it? I can start organizing some of the questions while you're still speaking in case any of them are duplicates, I guess. But if there are any you are particularly interested in addressing, feel free to just jump right in there.
because I have a recorded video, I can read the questions, I think, and already think about how I would answer it. So I think I will try to do that if it's possible.
Yeah, me too.
Okay, so I'm the one with the difficulties.
Yeah, but I can answer the questions for you,
Yeah.
Christoph.
Yeah, you can try it and answer. Okay, I see. That should be at the end. Yeah. Did not put my studio shirt.
I think we have 4 speakers, right? And currently we 3 have come. We have another one. The first speaker is not here yet.
Okay.
Oh, no.
Laura, yeah.
Is the sound better if I'm doing this or not? The microphone was not the one from my headphones, but from the camera, so I guess it's clearer that way, right?
Yeah, it's clear to me.
Okay.
Hi, everyone.
Hey, welcome, Laura.
Hi, thanks. Can I try to share quickly my slide to see that
Please
it
go
works
ahead.
fine? Okay, yeah, thanks. Okay, yeah, that works, I think. Up. Yeah, okay. Ah, thanks.
And so what is the order? It's first Laure and then me, Yue, and Mikey.
Laura,
That's right?
Christoph, Yihui, and then make it? Am I killing your name? How should I pronounce it?
Micah is okay.
Micah? Okay. This is a really different platform from last year, if I remember correctly. Okay, looks like we are live at the hour. Welcome everyone to today's session on publishing and reproducibility. We've got 4 presenters today. Get started right away because it looks like we have a lot of cool content. So first up is Lori Cognode on the clinical data reporting tool. And as a reminder, feel free to enter questions as they come to your mind in our Q&A, and we'll let the presenter address them at the end of their particular presentation. Please go ahead, Lori.
Okay, thanks a lot. Can you see my screen, my slides? Yes, great. Okay, thank you. Hello, everyone. I'm Laure Cugnot from Operantix, and I'm really happy today to present you a reporting tool that we created for clinical data review. So a key objective in clinical trial is to monitor the safety of subjects. So that's the main goal of medical monitoring, which is a review of clinical data, typically the safety events, medication that the patient receives, laboratory values. So the typical process consists of having some clinical data, which is delivered to the medical monitors at regular time frames. So it can be every month, every 2 months. And they can receive this data as listings, so really plain table with all the information of what happened to a specific patient in the clinical trial. If they are lucky, they can get access to the data via dashboards. There are also other proprietary tools which exist for medical monitoring, but we felt there was a need to have a tool which could facilitate the ease of the exploration and review of safety data. And this tool should be first user-friendly in terms of software, so the end user typically don't have access, don't have any knowledge of R, and also the person that will make use of this report and create this report also typically are not always familiar with R. User-friendly in terms of data formats, so typically in clinical trials they use certain data standards as a study data tabulation model. But again, the medical monitors don't necessarily know the format, so the end output should be user-friendly in that sense as well. The output should be user-friendly. We opted for interactive visualization, interactive table, and versus really static listings. It should support the display of aggregated data, so data across all patients on the study to detect like trends, but also patient-level specific data. It should be standardized enough because the main goal was to apply this tool on a set of clinical trials around the company. But at the same time, it had to be flexible and also to support specific customization, for example, for specific study, when there is very specific requests and analysis of interest as well. But the main point was that the entire process on the tool should be compliant to clinical trial regulation. That means that it should be fully reproducible from A to Z. It should be traceable. If we deliver something to the medical monitor, we should know from which data it comes from, which data version, which version of the code. It should be archivable as well. And that's why also we didn't go for a shiny application solution, but really a reporting tool. And it should be quality control. So the tool we came up with is called MEMO, which stands for Medical Monitoring. And actually it's quite simple. It's a standalone HTML report, which looks like that. So it contains different chapters, which display a certain visualization table for each data set of interests. So you can see an example here, and you may recognize the book down formats. It supports aggregated and patient-level data, and the entire input and output is shareable and can be archivable. The entire R code is available in a set of R packages available in Chrome that I'm going to present. But first, I would like to show what the tool looks like, what kind of report we create. And I'm going to show you an example report available at these links. So this is based on a public dataset from a clinical trial, which was meant to investigate the safety and the efficacy of a specific treatment, which was called the xanomeline transdermal therapeutic system in patients with Alzheimer's disease. And in this context, they were typically interested in terms of safety by adverse events, vital sign evaluation, and laboratory evaluation as well. So this is what the report looked like. And the main idea is that you have different chapters here on the left for the different data which is collected in the clinical trial. I will show some examples. So typically the medical monitors, one of the first things I would like to check is how many patients have been enrolled in the study at this specific time frame. So they can see that in this tree map visualization, which displays the number of patients here in the study. So there was 254 patients, and the patients were all from USA in that case, and they were displayed in different sites, so different hospitals actually. And then for each site, they can see also the number of patients for each of the treatments. So here there was 3 different treatments: the placebo, low dose, and high dose of the xanomeline treatment. Then the next step for them is to check the adverse events. So adverse events are events which happen to a subject during clinical trial. Typically, they are not desired, but it's very important to have a look at what kind of event happened for this subject. In order to detect any safety signal of interest. So this is the same kind of visualization, a tree map system of adverse events. So here you can see, for example, there was 91 patients, actually 91 events, which was linked to cardiac disorders. And the medical monitors can click further on and, for example, see how many patients got atrial fibrillation. And the main idea as well is that typically, if they're interested about specific safety signals, they would like to see to which patient this happened, and also have an overview of the data for the specific patient. And it's what we integrated here. So if I click P now on my keyboard, P stands for patient profile, and we download this zip file which contains the overview of the data for these 5 subjects. So this patient profile is just a PDF report which contains a screenshot of the event and the meta information of the specific subject. So here you can see it's a man which received a low dose of the treatment from this site and from USA. He has quite some medical history, also of cardiac disorders. Maybe it's good to have that in mind. He received also some concomitant medication during the trial. So you can see from the day 0 of the trial to day 100, you can see he received this treatment twice actually, from 0 to 15 days and then until the end of the study. And typically what the medical monitors would like to see then is that, okay, are the adverse events that we see can be linked to treatment? So it's what you can do in this kind of report. You can see, okay, this event, this one, which was a moderate adverse event, occurred at around 15 days. At that time, the patient was treated. You can also compare with laboratory test measurements, like here, to see if some of the test measurements, like this one, is out of range. So it could be of interest to have a look at this data, or even abnormal. This one was abnormal measurements. And can also see the vital signs, so the evolution, for example, of the height of the patient, the weight, the temperature, and so on. So just a subset of things that you can do with this report. I won't go into details, but I will show it in the rest of my presentation. So now I will go a bit behind the scene and try to explain how this report is created. Okay, just zoom a bit. Okay, so each chapter of the report is created from an R Markdown document, which is stored in an R package. So you can see here there are 6 different R Markdown, what we call template documents, which are used as basis for the report. And then the second file that is needed is a configuration file. So this is a file in YAML format, which enables to set the input parameters for a specific chapter of the report. One configuration file corresponds to one specific chapter. And then all the different chapters which are created are combined into a Gitbook HTML format thanks to the nice bookdown package. Each chapter is created also in an individual R session for reproducibility. And it was also important that if there is an error which occurs during report creation, the user can easily debug it, which might not be easy if the chapters are created in individual R session. But via this approach, it's relatively easy to debug because you just need to import the input parameter from this configuration file in R, and then you can just call render on this R Markdown file, and you will reproduce the specific chapter. So chapter with similar content, like the tree map of number of subjects or the tree map of adverse event that I was showing, are created from different configuration files. This is an example, 2 examples of configuration file, but they are created from the same R Markdown template document. So here you can see this is based on this template, which is available in this package. The user can also specify, create his own templates, import them in his own package, and that will work as well. And then the user can specify some input parameter for a specific chapter. Here we use a demographic dataset to count the number of subjects per treatment arm, per country, per site. And we wanted to visualize the tree map. Whereas for the adverse events, we wanted to have a look at the adverse event data. And we wanted to count the number of adverse event code by adverse event body system and display that as a tree map and also as a sunburst visualization, which is in the report. It was also important for the person that will create this report that it's possible to customize the report to their ends. And for our user, we also have the possibility to specify this tag to enable to specify parameters that should be evaluated as RCode. But we also wanted to have a way to specify some RCode that should be evaluated not when the input parameters are imported, but actually at the specific location of the report. And that's why we created this tag rlazy, which stands for lazy evaluation, because it's only evaluated when it is actually requested. We also wanted to have some way to check the input parameter for each chapter. And for that, we propose a solution. So we created a JSON schema documentation file for each of the R Markdown template documents. This is an example here for the report which creates this tree map. And this file contains the description of the input parameter. You can see here for the report. And it is used to check, for example, that all the input parameters which are required are well specified. We can check as well if they are of the correct type, if there is a certain object that should be used. You can also specify it this way. And this JSON schema file is actually twofold. We also use it for a second purpose, because we also realize that you can extend this JSON schema specification. And we created for each of these parameters as well a doc field here, which contains the documentation of these parameters. And all of that is available in the R package. And when we create the R package with R command bult, this file is converted to R documentation format. And then the user can see here, like the input parameter for the chapter in the standard R documentation file. I will go quickly on this one. So all of the reporting part and the interactive visualization were done via Plotly and are available in the Clean Data Review R package, which is available in Cron. The patient profile I was showing are also available in a dedicated package, so they can be used out of the memo report. The summary tables, I didn't have time to present, but you can also include the summary table of descriptive statistics. And we implemented that in an interactive format as well, and also static format. It's available in different package. And there is also the possibility, which was important for the medical doctor, to compare different batches. So typically they can collect, like for a big study, 15, 20 different batch of the data, for example, every month. And when you have a lot of records, a lot of events, it's very useful for them to know which records are new, which records have been changed, and so on. And it's also something that we provide in our report via interactive table here. In terms of reproducibility, so all the input data, the configuration file are stored in the data repository with versioning. The code is stored is versioned with Git. And also each report is generated in our platform based on Docker. So every time we have a new version of the package, of the tool, we deploy a new Docker image, and the user can specify which Docker image he would like to use to create the report. And then I will finish by talking about validation. So it was very important that all the different tools were validated in this clinical trial context. So we included quite some unit tests in the package, and it was also important that every time we release a new version of the package, we need to have a proof that it has been validated. And for that, we created like a custom document, a Word document actually, which contain the result of the test, the different user requirements, the code of the test, and so on. And this form is delivered at each new version of the package, and is signed as well by the package developer, the package reviewer, and also some representative from QA. So to conclude, I would like to mention that this is just an extra exploratory tool for review of clinical data by the medical monitors, which is meant to be traceable in terms of output with this configuration file. The output should be and can be archivable and shareable with different users. It's quality control, but it's again tailored to this very specific use case of medical monitoring. In terms of future work, so currently we started to apply this report to bigger clinical trials, so typically phase 3, phase 4, which can go more than 1,000 patients or more. And it creates some challenges. So we're currently working on trying to improve the report creation time and also the report loading time, because it's a lot of data that need to be rendered. Maybe interactive patient profile, and we're also working on the publication. So the demo is available here. I will put the slide after the meeting, and all the packages are available in CRAN. And to finish, I would like to thank all contributors, the people who developed the code with me, and also the entire team at Galapagos, which is as the initiative of this tool. And I must say it was really a cross-project work, so it was really challenging and enriching. Yeah, I think that's it. I would be happy to take questions if there is still
Thank you very much, Laura. We do have questions. So is the report that you're generating, is that one HTML file, or is it a set or folder of several linked files?
Yeah, it's a set of indeed a linked HTML file, and it's based on Bookdown, so that's something that Bookdown supports. And it was, I can also say it was actually a very nice functionality for this specific use case, because like I mentioned, we're dealing with quite some data, which means that we have really a lot of visualization, and having all of that into one HTML report is really not feasible. It takes
your
way too
users
much time to load in the browser.
Your users receive just one file, publish it.
No, so they receive a set of HTML files, and then there is a front page, in which I can access the different section.
Okay, so then the follow-up question to that was the size of the files. Does it get?
It's a good question. Exactly, it really depends on the size of the clinical data. Like the phase 3 I was dealing with was a few megas, maybe 100 of megas. So that's pose other challenges indeed in terms of storage. And
because I had a similar problem in my own work too. As soon as we throw in a few maps and Plotly, it became like ginormous, and people were not happy about it in their emails. So that is a good question.
Indeed.
Okay, so I think we have covered all the questions. So thanks again for that presentation. Really cool to see that in the Bookdown form. Next up, we have Christophedevil, and he will be presenting on knitter engines. Please go ahead. The floor is yours.
Hi. So I think you can see my screen and hear me okay. So let's go. I'm Christophedevil. I'm working at RStudio in the R Markdown team. So I'm a software engineer there, helping maintain some of the packages. And today I want to talk to you about Knitter Engine, and specifically Knitter, not only Knitter. So how to use Knitter to do other things that just evaluate our code. For the contest, the first thing I wanted to remind everyone, I think everyone knows R Markdown now, but how the R Markdown workflow is working. And so R Markdown is a tool to create some publication in several output formats by writing text and executable code together in the same document, and then mix that to get a single output format in different formats. And so Knitter is the first tool in the tool chain that will bring these literate programming features by sewing together code and results with other text in the knitting process. So the other tools for the conversion are Pandoc and LaTeX if you are providing PDF, but Nitar is really the heart of the process, as this will allow to execute some code, do something with the content that you have written in the file to transform that into a static content to do further things. And so this is illustrated in the left image by Alison Horst. Like Armageddon is seen as something that where you mix text code and output, and so it's kind of magical, but in fact it's a tool chain that it's nice to understand in order if you want to tweak some configuration. So let's dip deeper into Nitar. So what is a Nitar engine? So I'm using R as example because this is the most known. So on the left, you will have the usual setup chunks. So ops underscore chunk is what you would use to set a global option. Here I'm setting equal false for my whole presentation. And so I will use the R code chunks for that. And on the right, you get the schematics, like the template of what a code chunk and engine is. And so the first part after the brackets will be the engine, and it defines how the code content will be processed. Then you will have some configuration. They are provided in the syntax using key equal values as configuration for the engine with a special one called label, which is the only unnamed option in the process, but it's equivalent to using the label option basically. And so key equal values, key is a usual standard R name, like you can use the same syntax that R allows, and values can be any R code evaluated. So this is the usual syntax that you can use in a Nitar engine. So every engine that we will see after will use this syntax. This is the art of Nitar. And as you can see in this slide, there is a lot more than just R. So here I'm just listing the 50 engines that are available while building my presentation, which is made with Sharingan. And so R is only one of those engines. And so there is this is a subset of available engine for Nitar that Nitar knows in my session. But as you will see, you can add more and even add a custom one. So let's take a tour of those engines. The first type of engine I want to talk about are the ones that are processing chunk content as is. Like they are taking the chunk content and they are not evaluating them in any way, not with R or not with other things. So the first one is the Verbatim Engine. It's quite new, so you may not know about it. And you will use that to include verbatim, R-Markdown verbatim syntax inside your output results. So before this engine, it was really tricky. So there was a trick in the R-Markdown codebook, if you read it, to include Nitar code chunks as is in a R-Markdown output format. So using the Verbatim engine, the content of the chunk, so the code content, will be taken as is and put inside the code block. And using the option lang, I'm controlling which highlighting language I want. So on the right, you get the results where the option is Markdown. So I will get the content highlighted and Markdown. But if you are not including R-Markdown verbatim, you can change the language, or by default, if you don't want highlighting, you can just say no specific option. So this is to include chunk content in a code block. And there is an engine that is based on this one, which is called Embed. It's also new. And this engine will be useful to include the file content in a code block. And so those two engines are really useful when you are making tutorials, a demo file, or explaining how to use R-Markdown, which we are doing a lot in the book or documentation. So you may encounter that in our source files. And so this engine is taking an option, which is file, and basically it will read the content of the file and put that as a code content, and then put the code content verbatim in the output document. So here it's another example, like don't bother with what the GS code is doing, but basically macro.js is the file I'm using for this presentation, so it's available in the session. And I'm just showing you here in the slide what is the content by just using the chunk you are seeing at the top. And so the language for the highlighting will be derived from the extension from this engine, but you can change it controlling using different options. So I invite you, if you're interested by this engine, I invite you to look deeper into the documentation. The last one on this series is the Aziz engine. It's not a new one. It exists since a long time. And this will be useful to conditionally add some Markdown or Markdown content into your file. So for example, here, it's kind of a simple example, but basically the random number is 4. Then I will include the part is my Markdown file. So Aziz take the equal option is a well-known option. It says like, show me the source in my output or not. So if I'm using that, on the right, the random number is not 4. So in my Markdown output, I don't have the included text. And if the random number is 4, then I will have the included text, as you can see on the right. So this is quite useful if you want to conditionally insert some content, for example, based on the formats. There is other type of engine that are a bit more, we will say, clever about what to do, and you will with the code content, but that they will take the code content and output it without much transformation. This is the CSS and JS engine, and so on the CSS engine, we'll take the code content and we put the content into a style tag in your HTML file. So these engines are useful in HTML output format only, obviously. And the JS engine will take the content and put that into a script tag. So they are useful if you want to customize your output directly without using an external file, like to demo something or to quickly customize or make tests. So it's a way to quickly add JavaScript or CSS if you know that. Another category of engine that you may know about are the ones that will run the code content with other things than R. So for example, here, Nita now has some built-in support for Python, for Stata, for Bash, for Perl, and other. As you've seen in the previous slide, there is more than 50 engines that Nika knows. And so for those engines, the chunk content is passed to the tools through system2. Basically, we are calling like you would be calling in your bash command or in your terminal, something like that. So the content of the chunk is taken. There could be some modification. Nita knows about how to pass the command line, what are the command line options to use to pass the content. They are evaluated in another process using system2, and then the resulting, so the logging, what is printing is give back to Nita and will be included in the output. And so more recently, we have added a new engine, which is called exec engine, which will allow you to do that with any command line you have on your system. So previously, Nita needed to bring support inside Nita for those engines, but with the exec engine, you have now a command option where you can pass any command line that is found in your path. With R, it will be sys.which, the function to know if the tool is known. And using the special option name engine.ops, you can pass some option to this exec engine. So I'm not listing everything there. You have the links, and you will have the links to the presentation to know more about what option to customize. But I'm just giving an example here with the node command. So I'm putting some JavaScript code that can be executed if I'm opening my node command line interface on my system. But here I'm just using a chunk with the exec engine, passing the code. This code will be written into a file, and this file passed to the command line, and it will be executed. There will be some results from this command, and you can see that below my source chunk, as I didn't set equal false, my source chunk will be outputted, so not with the exec highlighting engine because it does not exist. JavaScript will be put because the language is determined from the extension. I'm using specifically the JS extension here because not expect this extension from the file, and I will get the output as my output chunk. If I would put equal false in my extension, I would only have the second code block in my Markdown output. So this is a new engine that can be quite useful, or at least you can use any tool you want without us waiting for us to merge a PR or something. But obviously we can bring back some support into Nita for some engine because option can be quite long, and we would use probably this engine from now on in our tool. Engine can be more complicated and can also be gain more power by what is available in other package. And one of the things is working with interoperability. So I'm just listing engines so that you know the name, you know that they exist, and you can go look through some documentation. There's links you can follow. The first one is the SQL Engine that will allow you to run some queries using the DBI package. And so you won't have to call DBI yourself. You're just writing some SQL queries inside the chunk, and it will be called on the database based on the options. The Python engine inside Reticulate will be more clever than the base knitr engine because you can work seamlessly with R and Python by exchanging data between the two processes. So, and in fact, it's a default. If you have a Reticulate installed and you are using the Python engine, this one will be used. There is also some specific engine in some package, like the SCSS or SAS engine that are in the SAS package, or the BSLib engine that will use the BSLib package, and they are used to customize some HTML content by using the package feature. And again, you won't have to call the package function directly. In an R chunk, you can directly use the specific engine, put the content, and it will be processed by the function. And so how does this works? It works by extending knitr with custom engine that can live elsewhere than inside knitr. And so there is so much thing you can do, not just interoperability between tools, and maybe some of the package have some engine that you didn't use before. For example, the glue package has a glue engine, which basically the code content will be processed by the glue function. So it can save some typing, or it can be useful to demo things, or you can try it. The tech preview package tech preview is a package which is very useful if you have code snippet to execute, specifically if you have in a non-LaTeX output. And there is a tech preview engine that is the usage of the package, and will handle inserting some output based on the LaTeX. The code chunk will be some LaTeX snippet, and it will be processed and output correctly. And package like targets also leverage knitr engine. So the targets developer developed a workflow called target markdown, which will use literate programming to create the target instead of writing directly the targets workflow in the R file. So some people may be interested by this feature. And the D3 engine, the R2 D3 package will allow to use D3 using a D3 engine by just putting some JavaScript in the chunk, and it will be processed using D3.js. So how does this work? What if you want to do that yourself? It's quite easy. You just need, like, the function that allows to do that is knit_engine $set. This function allows to register by name an engine. So here, the example, it will be the foo engine if you would want to use that in a chunk. And what this function, so you provide a function with take one parameter, which is options, and it will be all knitr options possible, which are passed globally or on the chunk. And this option will be passed to the engine, and the code content is contained inside the option $code. And so basically, you can do just whatever you want with it, as long as what the function return is something that knitr can process. So knitr can process string, but it can also process some more complex content. So let's see some example about using this registration process. This example is quite simple. I'm just doing an upper engine, which will take the content and put it uppercase. And so as you see, I'm taking the content, so the code content in the option, like pasting together to get one string, applying the toUpper function only if the eval option is true. And results is an option that knitr knows, and if the value is equal to hide, I'm just doing nothing because the result asks me to hide things. And a more complex example would be like a redo of the Python engine, so just a simple one called py. And as you see, I'm taking the code content, I'm passing that in system2, like as you would call it in UR console. And then I'm using a special function called engine output, so which allow to do more complex things where you pass the option, what was the source code, and what is the output that should be printed. And so on the right, you get the results. So it executes the Python chunk, and I get my username. So this is how you would register. So I hope all this give you more ideas of what you can do, that you discovered a new engine and that you will be able to include one or in your project. So you will find the slide online with the repo if you want to see the source, and you can find me on GitHub and on Twitter if you want. Thank you.
Thank you, Christophe. Please feel free to type in any of your Christophe can take them.
Good question. Like, great. Everything.
I think it's overwhelming. I didn't realize how omnivorous it was, actually. I'll go with a question if no one else has any. Like, what happens if, I know, I've never tried it with Python. What happens if you have different versions of Python in your computer? Like, will it mess it up when?
If you are using with Python, it's by default, as I said, if you are using the reticulate package, which we really advise to, it will be the reticulate package that will handle that. And reticulate as a way to handle several versions or discover a new one or register a one. If you are using the basic knitr engine, that will be what is in your path. So the first one found by R. Like if you type Python in your terminal, that will be this one. So with Python, I really advise to use the reticulate package. And with other language, if you have an R package that is compatible with a language, like with Julia, you have R Julia, I suggest using that. But if you need to use a tool that doesn't have a specific package, you can still do that, and it will call the command line, so found in your path.
Okay. We have a question about if the knitr engines presented here are available or in Quarto.
Yeah, so for those who don't know Quarto, you can look for it online, but it's a new tool that is more large than Armageddon. I won't present that, but any R thing that you will do within Quarto will use knitr and will use Armageddon on behind. So and specifically knitr. So everything that is working in knitr should work in Quarto, and if they don't, just feel an issue because they should. So we have not tested everything. We are working, Yui and I, closely with the Quarto team. So everything should work like the code chain, but there is more feature in Quarto than there are in knitr. So the other way around is not true. Some things will work in Quarto, but won't work if you are using knitr in Armageddon only. So that's the main answer. But they should work, and specifically those engines should work.
Okay, thank you, Chris. So we'll hand it over to Yihui for the next talk. There are no other questions. So Yihui Shi will be going through Blockdown with us. Please feel free to take the stage.
Okay. Packages including Blockdown, which is the topic of my talk today. So today I want to introduce how to create a blog or a website with the Blockdown package that will hopefully be easy to maintain in the future. So before you create a website with Blockdown, I hope that you have already installed the Blockdown package in R, and I assume that you know what R Markdown is. I have a few optional requirements, but yeah, I would recommend them. For example, I would recommend that you have installed RStudio and you have a GitHub account and a Netlify account. You have already installed and configured Git so that you are able to push to GitHub. I have links on all these items, and I will share my slides at the end of this talk. So if anything is not clear enough to you, you can go back and check out my slides and follow the links. So the first part of my talk is about how to create a new site with Blockdown. So today I will demonstrate 3 themes in Blockdown. The first one is a simple one called Hugo Xmean. Second one is an intermediate theme called Hugo Pros. And the third one is an advanced or sophisticated theme called Hugo Payroll. So if you have installed RStudio, it's easy to create a new website from RStudio, from the menu, file, new project, new directory, website using Blockdown. If you don't use RStudio, that's totally fine. There's an equivalent way to the above method in RStudio, which is to call the function new site in Blockdown. For example, you can call Blockdown : new site theme equals Hugo Xmean. So next I will demonstrate how to create those new sites in RStudio. So from the menu, File, New Project, New Directory, Website using Blockdown. You can create a new directory and give it a name. For example, I will just use the name test xmin. So basically, I will create a new Blockdown website using the xmin theme that I just mentioned. I will open it in a new session and then create project. And then RStudio will open the new website project. So for a new site, if you're not familiar with Blockdown already, basically there are only two things that you may want to modify or update in a Blockdown project. First one is the config file, which contains a few configurations for your website. For example, the title of your website or other things like the menu items of your website or the footer. That's the first thing you may want to customize. The second thing is the content directory. That's probably the most important directory to you. The content directory contains the source files of the content of your website. So for now, it might be a little bit abstract to you, but I will preview the site here using the RStudio add-in serve site. So when you serve a site, Blockdown will preview your website in the RStudio viewer pane. So basically now you can preview your website here. You have a home page, you have an about page. So all these pages correspond to the source files under the content directory. For example, the home page is from the _index.r markdown file. The about page is from the source file about.md. So when you serve a site, you can actually live preview the site. So like if you update the source file here, let's say, let's change about Hugo Xmin to about Xmin. And if you saved file, Blockdown will automatically update the preview page in the RStudio viewer. So the update is it's very fast. It's almost instant. Like if I delete a paragraph here, it's immediately deleted here. So you can modify or update the source files here, and you will get a new preview. And also, you can create new content project using the add-in new post. Like for example, I will create a new post named test post, and you can choose post formats, Markdown, R Markdown, or with the extension RMD, or R Markdown with the extension R Markdown. So there are subtle differences between the formats. I will give you a link to the documentation later. For now, I'm just using plain Markdown format. So create a new post here, and you can see you can preview it immediately in the RStudio viewer. You can type some content here, save it, and you got a preview here immediately. So that's how you can create a new site and the basic structure of a new website. You can have arbitrary directories and subdirectories under the content directory. Let's go back to our slides. Introduce how to preview the site using the serve site add-in, or if you don't use RStudio, you can call the function blockdown : serve site in R. So normally you would only need to serve the site once in an R session. So when you're in doubt, you can just quit R or quit RStudio and serve the site again. And I've also shown how to create new posts or new content files using the add-in new post, or if you don't use RStudio, you can call the function new_post in R. So I've shown the Hugo Xmin theme, which is a really simple and minimal theme. So you can tweak a lot of things, the content of the pages, or I didn't introduce like the menu. You can see there's a menu at the top of the page. You can change them to anything, like change home to home page, or you can customize the footer here. Like change my name maybe to another, or save a new footer. So that's a very basic Blockdown site. So next I'm going to briefly demonstrate other themes. As I mentioned, the second theme is the Hugo Prose theme. And I will use eHuihui/Hugo-pros here. We'll open this project in a new RStudio session. So basically, Blockdown will download that theme and create a new site with that theme. I will not talk about this theme in detail, but I will just serve the site and give you a quick preview of the theme in the RStudio viewer. So this is also actually a relatively simple theme. So you can see there are a few cards on the home page which you can certainly customize. And the list of posts or a list of other types of pages are listed on the home page as well. Like you can see an R Markdown page here, or an about page, which is basically the documentation of this theme. So for the Hugo Prose theme, it's basically for writing articles. It's kind of like the Distill theme, or like maybe, or even the Quarto website. So this you can have a lot of elements on a page, like a table of contents, which is on the left-hand side of the page, and you can have any number of footnotes and side notes on a page. You can have elements that are super wide, like they can exceed the page margin, like the figure here, which is super wide. And you can embed elements on the on the margin of the page. You can have other elements like tables or an appendix. So this is another Hugo theme that you can use. There are some other built-in functionalities like the searching. You can type to search within this theme. So that's the Hugo Prose theme. The last theme is an advanced theme called a Payroll. So the repository is Hugo Payroll/Hugo Payroll. And let's create a new site. Because this theme is relatively complicated, it will take maybe 10 seconds to download from GitHub. So it's a little, but hopefully it will be done soon. And by the way, there are hundreds of other themes for Hugo, and I will tell you where to find them in a minute. Okay, the download is done. We are going to the Payroll theme. Again, you can serve the site. And see the pages looks much nicer than the previous two themes. You can have several types of content, like you can have a blog, you can have a list of projects, you can have a list of talks, or any collection of pages. It's a very nice theme. So I know some of you might have used the Hugo Academic theme before, and this theme might be a substitute of that theme, and it was created and maintained by RStudio. So to some degree, we can guarantee that this theme will work for a reasonably long time in the future. So this is the Hugo Payroll theme. So as I mentioned, there are many other themes that you can use. You can go to the Blockdown book to find some of these themes and a link to a list of all Hugo themes. So in theory, you can use any Hugo theme with a Blockdown site, although not all of them are thoroughly tested. So the second part of this talk is about how to deploy a site. There are two methods to deploy a site. The first one is a quick and simple one. So if you have never used Netlify before, you can go to app.netlify.com and sign in with so for this simple deploy method, the first step that you want to do is to run Blockdown build site in RStudio or in R. If you run that, you will get a directory named public. So this public is the site just built by Hugo. So once you've got the public site, you can go to Netlify, app.netlify. And click here, add new site, and select deploy manually. And then it will tell you that you can drag and drop a folder there. So you can drag the public folder here and drop it. And then Netlify will just deploy it just in a few minutes. So you can see the deploy log. Okay, the site is live now. We can open the link here. And here is the site that you just we just deployed. That's a really quick and simple method to deploy a site. And you can notice that Netlify will give you a random name. And normally I would recommend that you change this domain because it's like meaningless domain setting. Like you can edit site name and use a more meaningful domain name here. So that's a simple method to deploy a site, but there's obviously a disadvantage of that method, which is that you will have to repeat this step again and again in the future if you need to update the site. So normally I would recommend the next method using Git and GitHub, so which is an advanced method, but you know, it can be harder to set up, but you only need to set it up once. So once you have properly configured Git and you are able to push to GitHub, the site will be the site deployment will be automatic. So you no longer need to drag and drop anything to Netlify. So basically, first you have to configure Git. So I will not repeat these steps here. You can check out my slides later and go through all these steps. And then just the second step is different. Basically, you go to Netlify and create a new site from the GitHub repository. Let's go back to my account, add site, import an existing Git repository. You can click GitHub. So here I assume that you have already pushed the Blockdown website to GitHub. As I said, I have instructions on my slides, on my previous slide. You can go through these instructions and push your website to GitHub and then import that website project into Netlify. And after that, Netlify will deploy your site automatically every time you modify your website and push to GitHub again. So you no longer need to manually deploy your website. The third part of this talk is about how to troubleshoot a site. So as I mentioned in the abstract of my talk, so in the first 2 or 3 years of Blockdown, a lot of Blockdown authors, a lot of Blockdown users suffered a lot from a lot of problems like the Hugo problems and Netlify problems. So we have summarized our experience with all these problems and written a function named checkSite. So basically, when you're in doubt, you can run this checkSite function, which will diagnose your website and tell you some instructions. So all you need to do is to follow the tips from the checkSite function and make changes to your website. So I can quickly show you what checkSite does. Blockdown checkSite. So it will give you a lot of tips. Like the thing that you need to pay attention to is the to-do items. So whenever you see an item marked with to-do, that's something that you probably need to pay attention to and make changes accordingly. So if you have fixed all the problems diagnosed by the checkSite function, in theory, your site should be stable for several years, I think. So that's all I have for you today. If you have any questions, feel free to ask them on our studio community or Stack Overflow. Thank you very much. My slides are available at slides.yihui.org/2022-user-blockdown.html. Thank you very much.
Thank you, Yihui. Gonna repeat some of the Q&As that was happening while you basically that Blockdown doesn't require very recent versions of RStudio to run, but of course you will have to test for yourself. And then the difficulty or how difficult it is to switch from existing theme to another. Again, on different themes if they're compatible with each other. And then there is a question on the old Nemesis these days. How reliable is it?
Mm-hmm. Yeah, it can be extremely reliable if you don't upgrade Hugo. Two, don't upgrade the Hugo academic theme. Don't upgrade these two things, and your site should be extremely reliable for many years, I think.
Let me check. Are there any other questions? Okay, if not, I'll hand it over to Maike Steinhuber for the presentation on reliable scientific software.
The University of Mainz in Germany. Today I will talk about how to develop reliable scientific software in R, and I will use my own package, SPRTT, as an example. Just that you have a rough idea what my package is all about. SPRTT stands for Sequential Probability Ratio Test Toolbox. So far, you can use my package to calculate sequential t-tests, and right now I'm also developing sequential ANOVAs. These kind of tests are alternatives to fixed sample designs tests. For example, maybe some of you are already familiar with fixed t-tests or fixed ANOVAs. I also implemented a Shiny web app called Spirit. If you want to know more about SPRTs, check out this slide. You can pause here. When I talk to colleagues about how they do develop their software, I see that often they do not really test their software, or even if they do, their testing is very inefficient because they do it by hand and there is no automation process behind. Also, a lot of them do not use version control, and this leads to the problem that they have to fear to change their system later. To change, for example, if there's an error or a bug fix, or they want to update something and they have no version control, then they feel insecure because they could break something. And then people do not understand their code after a couple of years, even after a reasonable amount of time. They cannot really figure out what is going on. And this is a sign for badly written code. All these problems lead to unreliable software, lead to the problem that it is too difficult to maintain the software. And so bugs are not going to be fixed. And this is really problematic because, for example, in my case, I implemented tests. And it could happen that medicine studies or other studies that are highly important are done later with my, are then later analyzed with my package. And so it could be really critical if there is a critical error. So how can we do this better? How can we develop reliable scientific software? We have to look at the best practices for software development. So today I want to show you what clean code is all about: refactoring, software testing, continuous integration, and also version control system. Let's dive into clean code. I think we know this all. We do this very often. We write a variable like ink because we are too lazy to write it out. We think this is more efficient or whatsoever. But later, like after 1 year or after a couple of years, or even if we work together with different developers, we have no idea what this variable is doing, or what is this function doing. So just take the time and just write it out. Income per month is instantly clear what this means. Another thing is when you want to copy paste your code, this is a sign that you instead should write a small function. Functions should be small, they should be specific and clearly written. Another aspect is comments, or our comments. Comments are no excuse for unclear or badly written code. If no one understands your code and you have to give comments to it, think about just rewrite your code in a clear way. Also, you have to keep in mind that comments need to be maintained. A wrong comment can do more harm in the future than it does anything good. And check out the guidelines, for example, the formatting guidelines from the Tidyverse, from Hartley Wickham. It just becomes much more easier if the physical appearance of code is similar to each other. It's easier to understand. As I said before, write small and clear functions. This can lead to the fact that you have a lot of small functions instead of a large, really fuzzy function that is doing a lot of stuff. And then you can create a really clear hierarchy of functions, and it is very clear what is going on. Another important aspect is refactoring. It is important to understand that clean code is a process and not a state. So that means rewrite your existing code. If you see that there is a bad smell in your code and you have no idea what's going on, rewrite the code, make it better. And let's talk now about a very crucial part. It's software testing. And I really like the quote, "A test is the first user of your code." I will talk about testing strategies, test coverage, and continuous integration. When we want to test our software, we should start at the smallest unit. And these kind of tests are called unit tests. So in my case, it would mean that I would test my lowest level functions. I write test cases separately for every function. And in the end, I know that all the pieces work how they should work. Then after I know this, I can create tests of higher order, for example, integration tests, where I then see, do my functions work well together? And after all, in the end, I can, of course, also do a system test where all the functions come together and process. And if I'm also want to go to the highest step, I can also give my software to users, to end user, and ask them about their opinion. But if maybe we do not have to do the acceptance testing in scientific software, but really we should start with doing unit testing. It is not enough to have like 1 or 3 tests that start already on the system level. We really have to make sure that also all the aspects, all the small parts are really working. Here I have a screenshot from a really simple test case. Here you can see there are multiple tests. And here I have a certain expectation, expect equal, so that this function with this certain input produces a true output. Here, if I change the input to y is a vector or a list, then the input changes. So this is these are a bunch of small tests that I wrote for the getOneSample function. And later we see that if you do this for all the functions that we have a lot of functions, and we can run them with this comment. And this is really, really nice. So later when I'm right now developing something or trying to fix a bug, I change the code, I run all the tests, and then I can see if the code is still working or if I broke something. One thing that is really helpful if you want to write good tests is to look at the test coverage. For example, the statement test coverage means that's the ratio between the total number of statements and the statements that have already been executed by the tests. You should aim for at least 80 to 90% coverage. My aim is always 100%, but right now I'm developing. As you can see here, if you run this command, then you can see that here, these are my latest developments, my latest functions. So far, I've not written any tests for them, but my older functions, I have already a 100% test coverage. The next aspect is automation. It is important that when you update your software, you do a big bug fix, or you want to change something else. For example, you just want to rewrite your code. You do not even want to change the behavior. It is critical that you always run all the tests that you create, that you build your package on different operating systems if you later really want to publish it. That's a lot of work. And there is no reason to do that by hand. You can just use continuous integration. I, for example, use GitHub Actions. And all these processes can be automated. Another important feature that's really helpful is to use version control system, for example, Git. If you have no idea what Git is about, Git is like a really fancy and really great like Dropbox for software. It, for example, enables incremental changes in the repository. It creates a change history, and so on and so on. It's a little bit complicated system in the beginning, but it is really powerful, and it really later gives you this that you can really change your code. Because you know that even if you broke something, you can always go back in time and just redo it. Another important aspect is to write extended documentation. This is maybe not really relevant for reliable software, because your software can be highly reliable. But if you really go through all that process in the end, you also really want that people are using your software. And so I would really suggest to write an extended documentation. In R, this means to write vignettes and to publish them as a website. Here's a screenshot from my website of my package. And so far, I have gotten already over 3,000 downloads. And I have not done any advertisement. So I really think that people are typing in some keywords in Google and they find my website, and that leads them to my package. So I really can recommend this to you to really do write extended documentation. It is really helpful. For example, here, as I said, I have already 3,000 downloads with basically no advertising. After you have implemented your code and everything works, that's really nice. But it is really also important to think about that the code also needs to be maintained in the future, maybe even by other people than yourself. Clean code is a process. So refactor your code. Rewrite your code in a way so it does the same thing, but the code is clean. Do extended software testing and use continuous integration, so you do not have to do everything by hand. Use, for example, GitHub Actions. Also, how your website can be published over a GitHub action, so you do not have to do everything by hand. You can just automate these steps. And I highly recommend to use a professional version control system like Git, because this gives you the freedom and the security to really make large, major changes. And if you then change your mind again and think, oh no, I want to go back, you always can do this. It's really amazing. And also write extended documentation. Now you may ask, is it worth the effort? In the beginning, it may feel like, oh, there are so many things to learn, so many techniques, and so like a lot of new software that I have to learn. And it can be even really annoying and drive you crazy. But first I implemented sequential t-tests, and like 1 year later, I'm right now implementing a sequential ANOVAs. So I have to work with the same code that I wrote 1 year ago, and I run now in all these situations where I'm so glad that I can understand my code. My code is completely tested, so it is so easy to change something, and then I just run all the tests, and then I know it still works. So whatever I did, it did not break anything. And this is the reason why I really hope that my software will be stable in the future, that there won't be any critical problems or bugs, and that I can maintain and update. Or even other people, even if I cannot do it anymore, then other people can take over and work on my project. So that's my idea behind this. This is my reference. I highly recommend to read that book. And I really hope that you enjoyed my talk. And now I can ask.
Okay. Questions? So the first one we have, thank you, Mikey, again. Would you have some recommendations on when in the development process to write unit tests, especially if the requirements are not well defined or subject to change at that point?
Yeah, I think that's a really good question, because I run into the same problem. And I think unit testing, or at least because I work in science, so I really try to be as efficient as possible in my work. I start to write unit testing when I have the feeling that the system is more or less stable, or it should be more or less stable. So I'm not doing it when I write a completely new function. I write it like 1 or 2 weeks later, like depends how fast you're developing. Because in the beginning it can be very messy. I make a lot of large changes. So personally, I think I prefer to write unit testing a little bit delayed, but not too far in the back. So you instantly see if something is going wrong. Another thing is if you really struggle to write unit testing, you should think about how well is your code written. If you have really large, really fuzzy functions, it can become very difficult to write unit testing. So if you have a problem with unit testing, maybe you should refactor your code. So this can be a symptom or a bad smell in your code.
Okay. I guess I have a question from my own team, because none of us are programmers by background, and we're kind of learning to code as we go along and not really giving any thought to unit tests or continuous integration, which is very basic for someone from computer science. So do you find that it's worthwhile to master that on the side, or is it also worthwhile to look at code to a specialist and kind of have them help set up this sort of process if you don't have that background?
We have this problem very strongly in scientific areas. We do not see these problems usually in professional software development, because they know that the only way for reliable software is to use Git and unit testing and so on and so on. And in science, we often have the problem that we do not get paid directly for our software development. So we often try to be very efficient. And I think then at that point, we have to make a personal decision. Do we really want to build software that is reliable, also stable for the future? How critical is my software? So I decided for myself that when I'm implementing statistical tests, I really want to make sure that they work. Because I cannot sleep in the nights when I fear that I do not know how is downloading my package, who is using it. And I really think that I have to make everything that I can do, that it is really reliable. And to make software reliable, that is the thing that really professionals do. I have some contacts to people that are working in professional computer science areas, and they all use these techniques. So I really think it is important, but it obviously depends on the project that you're working on.
Mm-hmm. So we have a question from Michael. Some problems are easy to identify ahead of time and write unit tests for, but others only come up when you detect a bug. So how do you go about identifying the proper to run? Do you have a systematic process in place for developing these?
So when someone or yourself finds a bug, write a test for it. So in the future, your test covers this certain bug. This is a classical approach that in the beginning you try to get a 100% test coverage, but this doesn't mean that you really do not have any bugs. This just means that every line of code is at least once processed in one of the tests. And if someone finds a bug, instantly write a test about it. So in the future, you have this also covered and also fix it. So there are different ways how you can do it. Some developers write tests in advance, and then the test fails, and then they try to fix the bug, and then the bug is fixed as soon as the test is positive. Other people try to fix the bug first, and then when they think it works, then they write the test. So there are two different ways how to approach this. I do usually the second one, but you can also do the first one. I hope that was clear.
Thank you. I think we're right on time. And if there are any questions, feel free to get in touch with any of our presenters after this talk, and I'm sure they'll be happy to address them. So thank you everyone again for attending the publishing and reproducibility talk today. Look forward to seeing you the rest of the conference.
Thanks a lot.
Thank you. Bye.
Thank you. Bye.